Harshad sir. Hello, Harshad sir.
Yes, sir. Yes, sir. Yes, sir.
We can start for today's session.
Yes, sir.
Hello, everyone. Good afternoon. So it's time to start our present today's workshop, day three. So I request to Harshad sir, please proceed with your today's session.
Yes, sir. Yes, sir. I'm sharing my screen. My voice is okay for everyone.
Yes, yes. It's all.
Okay. 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 Good afternoon, everyone, and welcome you all on for a third session on the skill improvement program on PTC Creo. So let's start. I'm Harshad. So our today's agenda will be these are the topics we are going to cover on our today's session. First of all, we will start from the mechanism, and after the mechanism, what are the mechanisms we can create in the Creo, how we can animate those mechanisms, as well as the if you want to change the orientations and if you want to show the sections in the videos animations. So this type of animations you can create itself in the Creo environment. Next one is the weld design. Weld design also important while manufacturing. So for the in the weld design, there are lots of types: fillet weld, spot weld, butt weld types are available. So and the what type of welding we are giving. So while fabrication, while we are drawing, creating the fabrication drawings, at that time we need to define those welding symbols. So according to that standard welding symbols, the fabrication drawings will be completed, and the who is the welder, so he can give the accurate welding for that specific component by reading those welding symbols. Next one is the 3D annotations. As I told earlier, we can, by using these 3D annotations, we can eliminate the our 2D data, 2D work, and we can give the annotations, dimensions, geometrical symbols. Those all annotations we can give itself in the 3D models as well. And at the next, if time permits, we will cover simulation topics also. So in this simulation, we are going to discuss about the structural simulation, how we can uh, calculate the stress analysis, strain analysis, maximum principal stresses, uh, von Mises stresses, how we can calculate, and if our model uh, can stable on the whatever the constraining we are providing. So this type of simulations we can do itself in the Creo environment. So first, for a first topic, it's mechanism design. In Creo parametric, model assemblies using true mechanism constraint to support and enable the kinematic motion analysis. Generally, who needs this mechanism design? That customers need to visualize and understand the mechanism behavior using real world constraint to validate mechanism design and range of motion. The business value of this, by using this mechanism design, we can reduce the product cost, we can reduce the time to market, reduce product life cycle cost, and as well as reduce product development cost also. For the in the process improvement, mechanism design and kinematic motion analysis we can do in this mechanism design. The technology and capability used in this extension, we can define the assemblies using the true mechanical joints like pin connection, slider connection, cylindrical connection, ball connections, slot connections. Multiple options are available for these mechanism joints. And after the defining the assembly joints, we need to design and troubleshoot the complex assembly mechanisms. Also, we can perform the kinematic analysis to validate and optimize the mechanism behavior. We can create the motion envelopes to define the keep out zones. As you can see in those images, in the last image, you can see these motion envelopes we can create. So these type of envelopes also we can create, and by using this envelope, we can define the keep out zones. Means whatever the area we have, we can give the motion of that part. So those area we can keep out zones. So any not obstacle will generate on these areas. So our mechanism also successfully run, and the other parts will also stay safe. We can drag the components easily to visualize and validate assembly mechanism designs and range of motions. How we can use this technology and capability, I will show in the live. And next, the model animation. We can easily create the assembly animations to demonstrate real world behavior and assembly disassembly instructions. By using these model animations, we can also create these our mechanism videos. Otherwise, we can easily create the assembly animation. Generally, who needs is the customer that creates documentation and collateral to demonstrate the functional and procedural products specification and details. It will reduce the product cost, lower product life cycle, reduce product development cost, and the develop and define new markets. So you can see in this image, here is the one assembly, how it will behave if we are giving its exploded state. So all those components will assemble in the sequence wise format. So this way we can create the exploded view, and we can also save these animations. We can easily define the display states, orientations, and motion behavior using a graphical timeline to create and manage the animations. And as well as we can define the assembly and disassembly animations for the shop floor service and repair. By using those videos also, the assembly sequence also we can also follow by using these videos also. And at the next, we can reduce or eliminate the need of creation of lengthy documentation. If we want to show this sequence of this assembly, we need to follow the lengthy documentation process while giving this sequence flow, or what we can say assembly process plan. So those process plan we can eliminate by using this model animation. In the next, the weld design. We can accurately define the weld geometry and the associated weld fabrication documentation. As I said, whatever the weldings we are showing on our model, on our assembly, so we can see in this first image, these type of standard symbols will generated automatically, and we can use these symbols in the detailing. So when we are going to create a fabrication drawing, at that time these automatic generated symbols we can directly use. At that time we have no need to define those weldings separately. We can directly import those welding symbols. The customer that needs to define and capture the welding fabrication process and manufacturing requirements. And the business value, again, the reduced product cost designed to realize the price premium. It will reduce the product development cost as well. The process improvement. As I said, we can show this weld design in the 3D weld definition, and it will also we can use in the 2D weld documentation. The technology and capability are used in weld design weld design extension. 3D welds are required to support the downstream activities like reference weld geometry to create the accurate structural analysis, perform accurate mass properties and interference checking, accurately access the cost and time estimates for the manufacturing, and it will accurately create the weld symbols and weld fabrication documentation. So how we can use those all these weldings, and how we can show and how we can use in this 2D documentation, I will show in the detail. And our today's next topic, this will be the 3D model annotations, which we can call as a model based definition. The shortcut is MBD. It's called as a model based definition. It 3D model annotations in which we can define a single source of truth of design. As I said, we can eliminate the 2D detail drawings. So at that time, we need to we can define the single source of truth for design, manufacturing, and process information. Finally, who needs it? The customers that want to improve the documentation and sharing of digital product information for design review and manufacturing. The goal is to reduce the reliance on 2D detail drawings and eliminate the lost time documentation, non-critical information. Sorry. So by using these 3D model annotations, the goal for these 3D model annotations is reduce the reliance on the 2D detail drawings. Most of the customers are dependent on the 2D detail drawings. So we can reduce this reliance on the 2D detail drawings by eliminating lost time documentation, non-critical information as well. Unlike the 2D data, 3D information is easily visualized and interrogated. So how we can generate this 2D detail dimensioning? You can see as well in this image the lots of geometrical tolerances, dimensions, symbols. Also, we can generate itself on this 3D model. The business value for this 3D model annotation is very high. We can reduce time to market, we can reduce the product development cost, we can improve the product quality and innovation, and improve the collaboration and communication. So process improvement in the model based documentation can use the dimensions as well as GD, geometrical dimensioning, as well as tolerancing. Can streamline the communication using a drawing free process. So by using this MBD, you can also directly give these 3D models. So by using this, we can create our work, we can complete our work with drawing free processes. The technology and capability used in this extension, we can streamline the product documentation by a drawing free process. We can eliminate the human error and misinterruption of 2D information, as well as we can define a single source of product development and manufacturing information. So if we create this type of all the dimensions itself on the model, at that time it will be single source of product development, and we can also we need to manage only single file. So at that time the human errors also we can eliminate, and the misinterpretation of 2D information also we can eliminate. So next one is the simulation. I will start with simulation extension. By using this simulation extension, we can analyze and optimize the structural integrity of part as well as assembly. So generally, in the Creo based package and all the student versions, the structural part assembly and part as well as assembly simulations we can cover the simulation in itself in the Creo environment on the part as well as assembly files. Who needs it? To the target customer must avoid the product failure to mitigate the risk of warranty, service, repair, and liability. So those customers want to validate their products before the market. So and they want to avoid the failures to mitigate the risk of warranty, services, repairs, and liability. So they can use this simulation extension as well. Also, the business value for it, you can reduce time to market, product life cycle cost, product development cost, product quality, and innovation. The process improvement, we can analyze the static structural analysis, linear static structural analysis, static structural analysis with small displacements, model structural analysis, linear buckling structural analysis, linear steady state thermal analysis. So all type of analysis we can do by using this simulation extension. The technology and capability are using in this simulation. We can seamless integration of design and analysis can enable this simulation driven design to optimize the product performance and the quality and durability. Again, in the linear structural analysis, as I was showing in this image, you can see we can give the constraint, we can apply the pressure or force on whatever the surfaces load will be applied, and after that we need to add the only material and we can run our simulation. Who needs it? The target customers must avoid these all similar. The only technology and capability same are the only I am showing the separate about the structural analysis. At the next, the simulation products overview. Generally for the simulation light, simulation elite, simulation extension, and PTC advanced simulation extensions. Those are the different light versions are available. Separate versions are available. As you can see, the capabilities in the structural analysis, static structural. You can simulate the part as well as assembly, buckling analysis, solid beams. You can design optimization, non-linear contacts, material non-linearity. Those all types of capability are available in the simulation advance. You can see in the at the last, and in the elite version generally for the T1, T2, T3 packages. So these type of functionality capability will be provided by these simulation extensions. So let's move towards the first one, which is the mechanism. Is my screen is okay? Please confirm, anyone.
Yes, sir.
Okay, okay, thank you. As you can see here, I am creating one slider mechanism. If I am dragging this mechanism, you can see. So this slider mechanism, for that sliding mechanism, I need to create the slider pin mechanism. Here also I am creating the pin mechanism, and here also I need to create as a pin mechanism. So how we can create those mechanisms, I will show. First of all, I am importing this slider way. So I am fixing it as a single position. You can see as in this assembly, you need to just call it and you need to fix it as a default. After that, for the pin mechanism, I will show again. In the placement, I am deleting all the everyone. This pin I need to fix as a fixed position. So for that, I am fixing this pin as a fixed position, and after that, I need to fix it here. And after that, you can see the pin mechanism I am creating here. And after that, I am importing the slider. How we can add this slider, I will show. So you can assemble, call this slider assembly, and after assembling, I will create this positions, rotation, axis, translation. Okay. So I am deleting this constraint type, and now you can see all my model is now all degree of freedoms are available. So here you can see in this list, drop down list, in the user defined drop down list, you can see the rigid, pin, slider, cylinder, planar, ball, weld, bearing, general, 6 degree of freedoms, gimbal, slots. How we can use the every mechanism. I will show some of the extensions. So here I am using the slider mechanism. I am selecting the slider. Now you can see for the slider mechanism, here is the first one. You need to provide the axis alignment. So how you can set this axis alignment for my model? I am selecting here as a this link, this edge versus this edge. You can see my first axis alignment get fixed, and after in the second I need to fix this rotation. Now you can see my only one constraint get fixed, and now you can see my I need to log this rotation version also. So for that I am locking my rotation with the bottom plane and the bottom plane of slider weight. Now you can see my slider will work very uh, smoothly. So for that, now again you can see the limits are not provided up to what area I need to slide this slider. So first of all, I am giving this leaving this slider as it is, and whatever the links are the available in between those, so I will create. So here again the pin mechanism, as I said, the fixed pin mechanism we have created here, because with the slider the pin should be travel. So if I am click on OK, and again you can see by using this dragger, you can see it will move as here you can apply. Next one is the small connecting rod we need to apply. I will so I am deleting those all the bottom components. Small connecting rod I want to import. Here you can see a small connecting rod. I am importing this small connecting rod, and here I need to add this pin connection. Here you can see. So I am selecting this pin mechanism. For that pin mechanism, I need to give the axis. You can see in the placement, axis alignment I need to give, and after the axis alignment we need to log the translation. So for the on the top surface I want to log this as this surface. I am click on OK. As you can see, if I am dragging this connecting rod, you can see it will freely rotate. So I need to connect this connecting rod with this slider. So for that I am opening again with the large connecting rod. So here again I am opening it, and now you can see. So I need to give again the pin mechanism, and for this axis with this pin and the surface on that the connecting rod top surface. Click on OK. Now if you can see, I can rotate freely, move with this slider as well, and for this also it will there is nothing any connection between those. So for that I need to create the connection by using this pin. I'm calling this second pin, and I am putting that pin as a pin connection. This first axis plane and the bottom surface and top surface of this plane. By right clicking I can select the bottom surface of any component, any geometry. So again I want to generate, I have created one pin connection with this small connecting rod, and I need to again create this pin connection with the large connecting rod. So at that situation again I need to give this examples, and for the translation display with display. Now you can see it get connected. If I am click on the distance and click on OK. Now you can see all the connections are getting properly work. Now you can see. this mechanism working. Control D, and it will work normally. So this is a simple way. By using this mechanism options, you can create this type of very simple mechanism. I am telling a different example for the mechanism. Now you can see I am creating here as a, again, slider mechanism. Oh, so here you can see the I am giving a short example as a shock absorber. See, I am fixing those two components, the rod and the bottom hook. I am fixing those two components as a default constraint, and after that I am using this top link. And now you can see again I will create for you the slider mechanism. Here is the slider mechanism. For that, first of all, I need to give the axis alignment. Here I am giving the axis alignment. Now for the rotation, you can lock also the rotation with this plane. I have locking this rotation also. So now we need to give the maximum and minimum limit for the shock absorber. So for that, here is the translation axis is available. For the zero reference, which references you want to give the zero, so you need to pick it. In the translation axis, first of all, I am giving this as a zero reference with this surface and internal surface of this piston of this. And see here I am click on the zero button. Now you can see I need this reference as a zero, set zero position. I have created here and enable regeneration value. Whenever I am regenerating my model, it will go on its origin position. So by those settings I can set from here. So minimum limit and maximum limit we need to set from here. I need to set this minimum limit as a 0 and maximum limit as a keeping here as a 250. Sorry. If I am click on the OK button, and after that I will drag my component. You can see up to 250 limit. It will go up to this above this shaft. So for that I need to re-edit this top link, and in the translation I am again entering the repeated this value. Now I am cross checking my, again it should be 100 and almost up to 100. Now you can see. So this type of way you can create this slider mechanism for the shock absorber. So I am applying the motor for it. I will show what is the use of this motor, and again how we can add the mechanism. As I said, these are the whatever the talk we have to talk this in about the mechanism. Those all the connection types, and we need to apply this mechanism. So here you can see the springs, dampers, force motors, bush, gears, cam, 3D contacts, and belt connections are available. Now I can add here as a spring. So exact running between these, creating this spring. And now we can see the simply 2D orientation of the spring is available. So we can adjust the diameter as well. Diameter should be enabled. And the K stiffness factor for the spring we can set from here and click on. Now you can see the spring get generated. If I am opening and closing the shock absorber, you can observe the spring will also connect with this element. So at this situation, I need to automate, and I want to check the mechanism analysis. So for that, I am applying here as a servo motor for this spring mechanism. And here you can see in this motor option, the driven quantity we need to set as a velocity, because the linear motion we need to give this upside and downside. In the profile details, you can see the driven quantity. As I here is the option also available. The initial state, use current position as the initial stage. We can remove these options as well. For the motion function, which type of motion function for this motor we want to apply, like constant, ramp, cosines, or the you can see the equations are also available for it. So here I want as a constant, so I am keeping this function type as a constant, and in the coefficient uh, for the velocity I am giving as a 10 mm per second. And in the graph window, you can see it will also generate the 2D graph for the connection. And now we are ready to run this mechanism. In this mechanism analysis, you can see here is the analysis definition name automatically gets set, and in the types, position, kinematic, dynamic, static, force balance option is available. Here we want to run as a kinematic analysis. So in this, by setting this kinematic analysis, here is the start point as a 0, and end point you can set as you want. I want to use this end time as a 20. In the motor element, you can see automatically what the motor we have added here, it will automatically get collected, and we need to just click on this run button. You can see it get run. So after the maximum position, it will get stopped. So click on the OK. So here now you can check this animation graphs, measure versus time, and we need to save this analysis. Here is also playback option is also available, so we can run this mechanism. Now you can see. So this way we can analyze and save these animations as well in the video format. So for that, here is the capture option is available. Just click on this capture. Here is the format for the animation.mpg, and whatever the resolutions, which type of quality you want to give this for this video, you can generate from here. It will take this increase the your video capturing time, and click on OK. It will capture. Here you can see at this status bar, it will generate the separate frames for it, and after that our video will get created. So it will take time. I'm capturing this, keeping those resolutions as low as, because I want to create this video as of in the fast. The file name of this video will be automatically captured. You can see. So now we can go in the mechanism folder, and our SB, you can see here the 24 September 2020 3:35 time is available. So video get automatically created. Now we can directly run on this. So this type of video also we can generate for the every mechanism. So we have also created some of the other mechanism like chain assembly mechanism, chain sprocket mechanism. You can see. So these type of lots of mechanisms we can create in this mechanism. So again, I am built mechanism. Here is one video for the belt mechanism. You can see these type of mechanisms we can create using this option. So I am giving one example for the gear mechanism. I want to close all the assemblies. The mechanism, generic gears, and the gearbox is available. If I am rotating one gear, now here is the all gear mechanisms already created. I am deleting one of the gear mechanism. I will show how we can create again. In the connections, and see the connect gear connections, and you can remove also from this here. If I am now, you can see if I am rotating only one gear, you can see there is nothing any connection between those. If I am rotating this yellow drum, now you can see only bottom gear will get rotate with this teeth. You can see. So if I am rotating this one, you can see the adjacent gear, last gear is not still rotating. So how we can create this gear mechanism? Here you can see in this connection mechanism option, in the connections, the gear options is available. So for that you need to select gear. Here is the types of gears are available: spur gear, bevel gear, worm gear, rack and pinion gear. Here I am selecting the generic type, the spur type. The first gear, what is the our first gear will be? I need this first gear as a, I need to select this first gear as a motion axis, this one, and for the second one I need to keep this as a second. So for the first gear I need to set the pitch circle diameter of the gear. So for this model I am setting my pitch diameter as a 12 mm, and for in the gear box, and my pitch circle diameter will be 24 mm. I am applying it, and if I am click on just, these are the only simple two steps are available for that. So now if I am rotating one of the gear, now we can see all the connections get automatically rotated. So here again also we can add the servo motor. Click on the servo motor, give the servo motor on the any one of the pin connection. Click on the angular velocity, and in the angular velocity we need to define the coefficients of angular velocity. So here I am setting the 100 degree per second as angular velocity, and click on OK. Now I want to run my analysis here as a kinematic analysis, and I keep on the running in the motors, and I need to remove, and if I am rotating here you can see the kinematic analysis automatically get run. So for that also we can create the snapshots also for the mechanism. For the initial position, final position, we can create the snapshots from here also. And for the cam and follower belt mechanism, I am showing one example for the belt mechanism. And now we can stop with the mechanism option. Belt mechanism. Okay, open. I need to click on the assembly. Now you can see here is the 3 pulley are available. So in those pulleys you can see if I am dragging the every pulley, it will separately rotating. If I am dragging this one, it will also separately rotating. If I am dragging, this will also separately rotating with pin connection. So here I want to generate the belt mechanism. In the applications, you can see the mechanism option, and in the mechanism here is the belt connection is available. So for that you need to select the in the references you can see the you need to just select the circular surface of this pulleys first, second, and this third one. You can see automatically belt connection orientation you can see. So if you want to give this as a bottom side, here is the wide drop is available. So by using this dragger you can switch the these types of belts. So here is the E into A value for the belt mechanism for the sizes. You can set 10,000 Newton, kilonewtons, multiple options, and in the again for the every pulley, body 1, body 2, body 3 number of wraps you can generate. So, and if I am dragging one of the component, you can see automatically all get rotated. I need to set that value for the belt mechanism. Here I can re-edit, redefine this 600 Newton as a 6 kilonewton, and again I am rotating it. You can see. So this way we can create the mechanism. If I want to skip the middle surface, so I am pressing the enter button. Now you can see it will again get coupled. So again we can drag these components. You can see only 2 pulleys will get rotated. So this way again you can use this cam and follower. You can measure your graphs. You can play back these mechanisms. You can give the servo motors. So this way you can analyze your mechanisms. So how we can create the animations? For the animations, here is the separate animation option is available. So for the animation, separate toolbars are available. We need to add this playback option, create animations. In the new animations, we need to add the import from MDO, the playback files. We can save these playback files. Closing. I'm setting the exploded view. You can see for this exploded view, I can re-edit these positions. I am pressing the control button for to reposition this exploded view. And you can see similar way I can click on the OK button. If I am now disable this exploded view, you can see these parts will automatically get again assembled. So I want to use this exploded view in this animation. Click on the animation. Here is the exploded view animation available. Animation 2, bell start. Click on OK. And in these sequences, key sequences, you can create views. As a back view, I want here as a default view as a standard from 0 to from starting to 2 seconds. I want this as a default view, and after this and click on apply. Now you can see here is the default option is available. Again, I need to change my view as a back view from the end of animation to up to 5 seconds. Click on apply. My animation time will be 3 mm. Start one, default one, sorry. From the default to 3 seconds, I need to keep on this, apply. And again at the end, this as a my last view. So for that, front, back, can set from up from the back button to 6 mm to apply and click on OK. Translation transparency, we can also add the transparency for the parts from the type from back view to 5 seconds up to. So this type of way we can create the animations for it. Click on close. Now I want to play the whatever the animations we have created. Just click on the play button. The video automatically get played. And you can see the transparency option will get automatically our parts orientation we can set from here. The time domains are available for at what time we want to which we want to see. So this way you can add the again multiple views for the back to start to default. You can change the colors as well. Again I am playing this video. This is the playback option is available. Click on yes. Now we can see. So this way multiple animations we can create. So whatever the animations we have created here, here is the save option is available. Click on the save. Again the MPG video format will get generated. Click on the OK. And the all the frames will get counted and the video will get saved. So you can see in the status bar, the frames get generated and the video get completed. Now we can again see this belt pulley mechanism. Here is its location. We can in the belts. Here you can see, and we can directly play in the our video player. So you can also render frame images, so it will take that much amount of time. So this way you can also create the animations. You can save this animation playback files, and I am now switching over our next topic, which is weld design. Up to now, if you have any questions, we can discuss. So before going to next topic, if you have any questions about these all mechanisms and animations, you can ask. Here,
Excuse me, sir.
yes, yes.
Um,
Yes, please ask.
Sir, can you please tell about 3D contacts?
Okay, for the 3D contacts, I am sharing again that specific mechanism folder. In this mechanism, here we can use that 3D contacts. So I will show. Now you can see I am creating here as a pendulum. You can see if I am rotating, this part is freely rotating, and if I am still this part also you want to rotate, it will also freely moving and freely uh, oscillating it. So now we need to create the 3D contacts between those two components. So for that, in the applications tool, we need to go again in the mechanism, and here is the 3D contact option is available. So for that, which surfaces you want to 3D contact with each other, you can set with each other. Here is the friction, with friction, no friction option is available, and we need to just click on OK. If now you can see if I am dragging the one component with each other, now you can see it get the 3D effect with each other. You can see the 3D effect will get generated. So this is the use of this 3D contact. Have you got this?
Sir, can we use this effect with flat surfaces?
Yes, yes, yes. We can also use this with the flat surfaces. I am showing one more example. Mechanism. 3D contacts. Click on the open, and here we have one assembly. Now I want this whole rectangular cube with 3D contacts with all the surfaces. Here you can see in this model tree, I have created total 8 surfaces with every surface with this as a 3D contact. You can see in this mechanism, we have created the every surfaces with this cube as a 3D contact. So if I am dragging this component bottom, now we can see it will get locked. So this type of 3D contacts also we can generate. If I am running this analysis, sorry for that, we need to add the gravity for it. Click on OK. How we can run this analysis? Here you can see.
Sir, we will need dynamic analysis, right?
Yes, yes, yes. For that, for the dynamic analysis. No, still it will stop because the how it will come the downward direction.
Sir, there is option to enable gravity in dynamic analysis, I think.
Yes, yes, yes. Sorry. The external loads enable gravity option is available. Enable all frictions. So now you can see the where we have created that 3D context. Now you can see those surfaces still in the 3D contact. Our model will get in the running position. It will take the time which we have given here the duration. So we can count this duration as a low in the external, and again we can run this mechanism. So this way we can, I'm regenerating my model. So this way we can create this 3D context between the flat surfaces also. It will take some time, so that's why I'm closing this mechanism. So you can run these mechanisms also. You need to add the gravity, and after that in the dynamic analysis you need to enable gravity and enable all frictions options. Have you got this point?
Yes, sir.
Okay. So in the chat box also you can see the various animations videos we have shared with our YouTube page. You can also watch these videos, and also you can try your own, and you can also share your ideas with us, so we can share those videos also on our YouTube page.
Excuse me, sir.
Yes.
Sir, I have tried this 3D context before. I did 2 or 3 entities at a time, falling down a slope, but it took very much time. It's literally 1 to 2 hours, and it was not completed the analysis. So, what can we do to reduce this time?
So at this situation, it will not take that much amount of time. If I am my system is also taking too much load, so for this system configuration should be our higher, so it will not take that much amount of time, because the simulation type of extensions also we can run. So it should be our system configuration should be as optimized level, and
Okay, sir.
this 3D context will take the time for it. Any other questions? Can we move further forward?
Yes, sir. Sure. Thank you.
Okay. Okay, thank you. So our next topic is weld design. I'm opening one special assembly for the weld design. You can see this structural assembly. So by using this structural assembly, we need to add the fasteners, we need to add these weldings. You can see I have given these welding symbols at here. At the bottom surfaces, the connecting plates we need to weld with these legs of that table. So how we can create these weld symbols? I will show. In the applications toolbar, the welding option is available in under this engineering tabular format. So when you are going in this welding, you can see the visibility, setup, datum, insert options, and editing options are available. So where you want to add this welding, you need to set this type of weld: fillet weld, butt weld. You need to set this fillet weld, butt weld type of any type of this welding. So I'm selecting here as a fillet welding, and one side or two side you can select from here. Here I am just selecting as a single side. Next one is the, we need to select the side one and side two. Just simple select the side one and side two. I'm just removing some of the weldings, so I will show with best examples. I am deleting this welding feature. Again, and this surface, I am deleting it. I am regenerating my model and I am save it. Then I am pressing the keyboard Control D shortcut key for the default orientation. Now you can see the default orientation will be Control D. We can view. So here I want to add the welding. So you need to go in the welding in the fillet weld tab. Here is the location option is available. For the side one, I need to select the bottom surface as a side one, and for side two, we need to select the surface. And here is the size for the welding as a 5 mm will be size for the welding. Now we can see if I am pressing the control button for while selecting the side two. Here I am selecting the side 2, side 3, and the internal surfaces. Now you can see all the loop get automatically completed. So this way we can show the weldings also in the options toolbar. Here is the some types or geometry, welding geometry types are available. If you want to show just lightweight welding symbols, lightweight welding geometry here. So for that you need to select the surface or light option. So at that situation, welding symbols automatically get generated, but this feature will only took sorry lightweight geometry. So in the welding cross section, we can weld cross section. We can set by value. Weld material we can set from here. If you we have some if you want to add the welding materials as well for the calculation of the uh, weight of this model, so we can set the weld material, weld processes also we can set. And here is the all round welding symbols, about the welding symbols. Fillet, if you want to add the fillet filled weld or the finish weld, which type of welding we want to show. Contour for it, convex, concave, which type of contour we are showing, we can set from here. And in the symbol gallery, now we can see the type, the size of welding we have adding here as a 5. After this 5 automatically get added. The finish type of symbol we want to add here, so finish symbol is adding. And then the convex shapes symbol also get generated. So this type of standard welding symbols automatically get generated. You can create, and the other side also we want to separate symbols, so this way we can add this. So again, here is the some one option is available. By click on this option, you can see the stagger welding means if the long surface is available with the long component, at that time we need to create as a stagger welding. So for this stagger welding, we can set its size from here as a 10 mm, which type of 50 mm we want to set as a stagger welding. And here is the number of elements. If I am entering the 5 and I am setting the value as a 20 degree, now you can see the stagger welding automatically get generated. So again, if I want to show the stagger welding on the other side, now you can see in the fillet option, locations, again side 1 I am selecting this one, and side 2 will be this one only. So I am setting its size as a 5 mm and as a stagger welding with the 5 mm thickness and 5 different places. You can see, and again you can set as a solid, so it will get generated. If I click on OK, this stagger welding get created. Again, for the butt welding, we should have the uh, groove for it. If we are adding the V butt welding selection, the first slide here you can see the side 1 and side 2 options we need to select. It will not there, yeah. So for that the groove should be there. If you want to use this different types of welding, butt welds, square weld, bevel weld, so we need to set this different. And here is the some combine option is available. You can see for the references reinforcement material if you want to add, and references other side. Click on OK. So combine welds you can see. So those two symbols automatically get generated in a single. So combine welding symbols, weldings we can give one, and we can add this as a single symbol. You can see. So this way, this is the welding processes preferences options is available. Weld standards, as I stated, the some standard weldings options, welding symbols, and the welding orientation, welding aesthetic looks we want to give. Here is the option is available, like ANSI and ISO standards are available. We can set the process also. Also, we can add the welding material. So this is about the welding. So now you can see in the whole my assembly, I am adding the multiple welding. If I am going in the drafting window, here I can see the apply and OK. Now I want the welding symbols at the bottom area, and now I want to detail view at this specific point. And here I want the detail view, and now I want to add this welding symbol at here, which this stagger welding we are adding here. So here is the option for it. You can see. So multiple welding symbols automatically get generated. So this way, selecting the welding symbols. Here you can see for this one and for this specific one. You can see apply. Okay. So for this specific view, I want to show this welding symbol, and it will automatically get. We can use as it is in the drafting window also. So if I am showing this all the welding symbols at this stage, you can see all the welding symbols get generated. So we can manage this as we want. So this way we can manage all the welding symbols. At which area we want to show the different welding symbols, we can show by this way. So detail view also we can show this way. So okay, let's move towards the next topic, which is the 3D annotation. We can call also the model based definition. I'm giving the best example again. With working directory and model based definition. Open. Now you can see for this model, I want to give this model for the manufacturing. So for the giving this manufacturer, he will ask again the 2D detailed drawing. If I will add this all the dimensions itself on this model, it will reduce this my 2D detailing time. So in the by using this model based definition option, model based definition extension, I can add all the dimensions, geometrical tolerances, and the dimension tolerances itself on the 3D model. So here you can see, if I am selecting the top view of my model, I can also add the note on our page. Here you can see. We can also add the note. We can also add the what type of standard tolerancing symbols we are using. You can see. So how we can add these 3D model annotations, I will show. So for that, we need to add the tolerance tables, tolerancing standards we need to add. ISO for the ISO DIN standard. You can add the tolerance table. Click on open. All the tolerance table we can add, and click on done button. Click on close. So for the ISO tolerances, how we can show the values. So here I'm starting my dimensioning. For that, first of all, I need to set the active plane as a top as active plane, and after that, click on the dimensions. The dimensions outer OD, finished OD dimensions I have generated here. So for that, you can see I'm adding the shaft basis, hole basis tolerances. I'm hearing setting as a normal tolerance for the symmetric tolerance value, and here as a 0.1 tolerance, plus minus 0.1 tolerance from here. If now I want to add the axis for this hole, here is the show annotations option is available. Click on the axes. Apply. Okay. Here you can see all axes we have available here. So by using this, you can see now again we can add the dimensions for the slot. 30 mm total slot distance, and I want the add the tolerances symmetry 0.01 micron, and for the geometrical tolerances I want as a plane as a parallel. So for that we can set, you can see here is the parallelism option is available, and we can set the parallelism value as a 0.01 with the datum A. So by using this, Here I want to, if I want to re-edit this value, I can just click on it and remove the features. So this way we can manage the dimensions, tolerances. If you want to add the symbols, extra nodes, so this way we can add it. If I want to add the one node for the top surface on the front surface, here in the leader type of nodes are also available. Resting surface I want to add as a node. So now you can see. So we can also add this 3D model dimensioning itself in the 3D model. So when I am changing the view as a front view, you can see on the front view I am adding some of the dimensions. Again, I am adding more dimensions. Total distance, and again for the general also. .1. For the holes, we can add the different tolerances for the on the top view. Here I am changing my active plane, and here in the dimensions the OD will be 31.5. So I am here, I want to add the tolerances for the whole basis, and here you can see in the whole basis H7 I want to show, so automatically value get calculate in the plus minus. You can see I don't need to understand what is the H7 upper limit and lower limit for this shaft basis and hole basis. So this way we can add this tolerances at here. For the inner hole also similar way. (18° diameter 18). You can set here as a whole basis tolerance plus minus, and the value should be H7. So this way, and after the outer surface, if you want to add the just last dimensions 20°, if I want to add here as a shaft basis, so you can see automatically small alphabets are available for the shaft basis. H6 value, if I am adding here, you can see automatically the upper limit and lower limit for the tolerances automatically get available. So this way, if I am sharing this value as a 3D PDF, if I am saving this file, there is the one option we called as a 3D PDF. PDF view 3D, just select it, click on the, I want to show it on the desktop. Content, I want all the annotations here, you need to concentrate. Background colors we can set from here, click on OK. The 3D file will get generated. Performing PDF file will get generated. So we can, here you can see, if I want to activate this 3D, Now in the itself in the PDF file, you can rotate, you can check the views of this models itself in the PDF file. So if anyone user don't having this software for opening these 3D files, so you can share with these PDF files also, and you need to have this Adobe Reader, Adobe Acrobat Reader for the viewing these files. You can see all the dimensions available. So here we can also change the planes from the right plane, top plane. We have the 3D options and the if we are giving the cross sections, we can also see these cross sections. You can see. So this way we can give these files with the our non-CAD users also. So they need to just open. You can see all the nodes also get generated. You can see if I am selecting the front plane, all node get also generated. So this way we can also share this 3D model annotations for the manufacturing also. So it will save our 2D detailing time, and again the it will improve our productivity by saving the time, as well as the all the you can uh, eliminate our human errors also. So still now I'm erasing it. Tomorrow. Is there any questions regarding this extension, well designed 3D annotations? And ask. Okay. Simulation. So let's move towards the simulation extension. We have almost 20 to half hour we have. So we can cover this simulation extension. I'm opening one of my large assembly, and from that assembly I will call my split. Block advance. Open.
Voice not coming, sir.
Sir, please unmute
Okay,
yourself.
sorry. Now is it okay?
Yes.
Yes, sir.
Yes. Yes, sir.
So in this simulation extension, you will get this structural, thermal, and modal analysis option. So in this structural mode, you can do the static structural analysis. In the thermal mode, you can do the thermal analysis on which you can apply the thermal load, and you can just give the other constraining options. And next one, you need to apply the material, whatever the you want to simulate, that part file or component. You need to assign the material, and these after completing these three stages, you can directly run your analysis. So let's start with the structural analysis. So here you can see at these four corners I need to fix first of all. So for the in the displacement option, you can see the displacement constraint. Here is the individual boundary and indent options is available. So I am selecting the individual. So by selecting these options, I need to fix these four places, internal holes as well. So after selecting these surface sets, you can see the coordinate system automatically gets selected, world coordinate system. And in the translation, here you can see in the translation option, the free translation, fixed translation, and prescribed. These three types of displacement option is available. For the translation X, Y, Z direction, we are all setting as a fixed direction, because these 4 points I need to fix it. It will be fit by using these fasteners. So I need to give the displacement as of fixed point, and for the rotation I am giving this pre-rotation. I am completing first stage of this simulation. Next is the at the specific area what we want to add the force or the pressure, bearing pressure. Just we want to check the gravity pressure if you have any preload. So we can apply also preload. Centrifugal forces also we can apply. So here I am applying the force on this area, because as per the assembly requirement on this area, the pressure load will be applied. Now you can see in the force vector direction mm up to units you can set from here, and in the direction for the world coordinate system you can see the preview for the world coordinate system at the right bottom corner, WCS XYZ. So here I need to add the negative Y value as a 200 kilonewton, and we can just cross check the preview by using this preview button. So which which direction we are applying this load, and if we want to add the moment, so also we can add the moments also. Click on boundary indents option, so I will tell. So after giving those two constraints, after applying the load, after giving the constraints, we need to assign the material. Here the material assigning option is available. I have already applying the material as a steel, and here I am selecting the in the material properties the material assignment. Now you can see assign material option also get completed. So these three stages I have completed. After that I can directly run the mechanism. So here I have already done this mechanism. So I'm again creating new static analysis. Non-linear, linear, inertial reliefs options are also available. First pass, single pass adaptive, multi-pass adaptive options are available. In the output, we need to calculate the stresses, rotations, reactions, local stresses, errors also we can calculate. And in the external elements, if you want to add any external elements, you can also exclude the elements also. Just selecting this window, click on OK, and now you will see, and you need to run this mechanism on OK. It will also take some time to complete the mechanism simulation, and it will generate the one report also. You can see this log file also automatically updated, and in the simulation diagnostic report will also get generated. All the values, first pass, second pass options are available. And our almost all the values get calculated, and here you can see run simulation run get completed. Click on the close. Here is the status is completed. Just now we can check the results. Here is the default result templates are available. Okay, and show. The three templates will automatically set. One is for stress, the second one is the displacement, and last one is the principal stresses. So you can see first one is the stress calculation, von Mises stresses. In the kilopascal unit it is available. It is showing as an animation. Now you can see the deformation scale, maximum value, and the minimum value also we can observe. In the displacement, the maximum displacement will be 34 mm. So on this, in this situation, if this value is acceptable to us, we can keep it as it is. Otherwise, we need to change these values for our material, or we need to redevelop this plate. In the principal stresses also, you can see the direction of the arrows. The principal stresses get created. So if I want to change check this displacement as an animation, here is a deform option is available, overlay, transparent overlay, and show the loads. We need to animate it. In the display locations, quantity, displacement view, if you want to change the unit, you can change it on OK and show. It will also animate. Yeah, so 34 mm displacement, deflection will be 34 mm deflection will be there in this plate. So we need to redefine. If we want to minimize this deflection, we need to minimize this deflection. We need to redefine this thickness, or if you want to, we can reduce this our pressure or load. We can also reduce it. And after the whatever the results we have calculated here, we can save it on the desktop. Click on the save. And the file will get generated. Here is the RWD file get automatically generated. And for the simulation results, click on the close button, and whatever the values for the displacement stresses get created, it will save in this our working directory folder. Here I will see the analysis 1 folder automatically get. This is the analysis 1 our animation simulation result. So in this analysis 1 result, here you can see the one Excel file also automatically get generated. In this Excel file, all the results are we can observe, and we can cross verify all the results. As I said, the maximum displacement is also about the 34 mm. The maximum displacement in X, Y, Z direction, principal magnitude, maximum principal stresses, one mesh stresses, all the values are available at here. So we can use this report for documentation purpose also. So this way, all the analysis values and all the files automatically get saved. So similar way, we can close it, and we don't want to save this simulations. If I want to create the check the thermal analysis, here you can see we can add the load as a heat on these internal surfaces, and here is the value for loads megawatt. And I'm here adding as a 100 megawatt heating element, and the convection conditions, we can set the convection and prescribed temperatures from these surfaces, and normal temperature will be, we can show as a 20 degrees Celsius. Convection radiation condition we can set from here. All the outer surfaces we can define as a convection condition. Megawatt. All the, you can also convection coefficient should be, I don't have the values for it. I'm just keeping as a 2, and the bulk temperature as a 10. Review the H. Okay. Now, if I am analysis and studies, new steady state thermal, new transient state thermals analysis we can check. If I am running the analysis, the design study has started. Again, we can check the log file. So by using this log file, we will update all the status about the simulation process. Running thermal simulation get completed. Now we can go in the result. Open form template. In the analysis and studies, directly we can go for the result window. Okay, H. Now you can see the thermal load sets in the form of temperature. In the flux are also available. Temperature gradients we can check. The units we can change by double clicking on it. Here is the temperature in the degrees Celsius. We can check the unit in the Kelvin also. The maximum and minimum heat flow you can check from here. In the blue means the minimum heat flow, and the yellow means the maximum heating area. Here is some options also available for the model maximum and model minimum. So you can see the model minimum at which point we can observe at this area, and the model maximum is available on this specific area. So this way we can also highlight this model maximum, model minimum. So one more point I want to cover is structural simulation. In this refined model, as I told that if you want to apply these loads on the specific surface region, we can set the surface region on this specific area. We can sketch it. References, we can define the specific load area. giving the reference and on the specific area I want to apply the pressure load. It will behave as a separate uh, surface region. So while uh, simulation, the software automatically calculate the particle size, and it will automatically get calculated here from the auto geometric element automatically get calculated. We can also control the element size by using this control maximum element, edge length, minimum edge length, hard point, hard curve. By using those options, we can select the simulation option manually. So these are the some of the options. Like if you want to idealization as a spring, mass, shell, welding also we want to cover, consider in the simulation option. So for that purpose, we need to add those. We can use these options also. So if I want to apply the pressure, it will apply as a specific surface. Now we can see here I am adding the 100 preview. Now we can see on the specific surface the pressure will be applied. So this way, by using this refine elements option also we can use. And in the viewing options, remaining options are similar to other. So anyone having questions regarding the simulation? Regarding all the details, whatever the sharing with this chat box about the YouTube videos, the links we are providing, you need to just refer for the giving the more details about the every topic. You will get about here the every extension by reading this, viewing these videos, as well as by reading these blogs available by PTC. Here you can see in the PTC tips and tricks, create the solid welding options. So by using this, you can cross-check your knowledge also, and you can improve this your skills also. So any questions? Chavan sir, can we stop here for today? We have almost covered all the topics about the today's session.
Sir, can you show flow analysis?
Hello.
So yes,
Hello,
Yes.
sir.
yes, with problems. So for practice, please provide the problem statements or problems to students if you have.
Okay, for the practice purpose. Okay. I will share the models also, or the practical examples for the giving knowledge about for the every students. I will share with the WhatsApp group. If I want to show, I will give the drawings for the modeling practices, and if you want to try the different extensions like simulation or other, so I will give the models also. So you have to come with this model result. I will share this practical example for it on the WhatsApp group.
Hello, sir.
Yes.
Sir, can you show how to do flow analysis?
Flow analysis. Generally, those flow analysis are used for the fluid flowing. Here is the flow analysis. I have not prepared for it. So I will show any example or any video for it. I have not any brief idea about it. So for that I will show one video.
If not ready today, you can tell us tomorrow.
So here you can see the for the Creo flow analysis extension is available. So I am running one example. So in this flow analysis extension, we can use the air or liquid waters as a medium for the checking the flow analysis. Here is the lots of parameters we need to define. If you go on the YouTube and you will search the about the flow analysis in Creo, you will get lots of videos for it. I think it will take time and will take also it will also you need to define the too much parameters for it. And see this way you can check this flow analysis orientation in your Creo window also. How the fluid will flow with our part and what area we want to observe. So I have don't any idea about the flow analysis, so that's why I'm showing this video. I'm sharing this link with our chat box. Okay, any other questions? I will share these drawings for the modeling practices as well as the any other extensions. I will tell you on the WhatsApp group for the practices.
Hello.
Yes.
Yes, sir. I have a question. Actually, not regarding to this today's content.
Okay.
I just wanted to ask. Suppose if I'm creating a part in Creo, and I such as block, okay, and now I save it in the format of the part file, and further now I want to take that part or I want to import that part to the next version of the Creo.
Okay.
And I want to make some additional changes in that next version so that I can upload it to the another platform. So by converting that part file or by importing that part file from the previous version of the Creo to the next version, will it directly support in the next version or I have to make some additional changes in that or something like?
Okay. Uh, for if you are having if you currently are using the older version of Creo, like if you are using currently as a Creo 4, and if
Okay.
you want to use your current version 4.0 file and you want to modify it in the Creo 6 or Creo 7 latest version, so you
Okay.
can directly open and you can directly start working on it.
Okay.
So if you are working on the latest version and after that you want to move and you want to modify your current model with the older version, like if you are
Okay.
using with Creo 7 and you want to open your Creo 7 model with the previous version, like if you
Previous
from
version.
the
Okay.
that will be not possible. So if you want to directly open that current latest version file with older version, there is a long process to opening the latest file in the older version. So you can go from the older to latest version very easy, but the from the latest to older it is some difficult process are available.
Okay.
You can work on both, but from older to latest you can go very easily. There is nothing any problem.
All right. Thank you.
Okay. Okay, Chavan sir, can we stop here now today?
Yes, sir.
Okay. So have a good day for everyone. I will share the tutorials for the everyone on the WhatsApp group. Okay. Thank you.
Thank you, sir.